When it comes to naming hydrocarbons, you want to be sure to follow the game plan. The 3 steps laid out for you here will allow you to name any hydrocarbon correctly. The best way to see them in action is to just go ahead and tackle a few examples. Before we do that, make sure you have the functional group sheet with you. On the back of that functional group sheet are 2 tables that will help you name hydrocarbons. The top part of the functional group sheet will help you name the long continuous hydrocarbon chain. The bottom half of the back of the functional group sheet will help you name the branches that come off of that chain. So let's go ahead and get started by drawing the 2 structural isomers for C4H10. The easiest way to do it initially is to just draw a string of 4 carbons bonded together. So 2 different ways to represent this. Just drawing it out and showing all the bonds to hydrogen. Another way is written like this, where you break the hydrocarbon into chunks, and after each carbon, you write how many hydrogens are bonded to that carbon. Then you need to be aware that each carbon is also bonded to each other. So if you see this carbon here has 3 hydrogens bonded to it, and it's bonded to the next carbon. Well, we can represent that by saying CH3. This carbon has 2 hydrogens bonded to it, and also bonded to 2 other carbons. That's why it says CH2. Anyway, to name this, you follow the game plan. So you circle and name the longest continuous strain of carbons. Well, in this case, it's just this butane strand right here, 4 carbons laid out right in a row. So this is butane. If you go to the next step, it says start numbering the chain from the end with the most branches. Well, this molecule doesn't have any branches, so you don't need to do that step. This is simply butane. You're done at step number 1. The other way to draw C4H10 is like this. Notice there are 4 carbons here, and there are also 10 hydrogens if you count them up. You can also represent this structure like this. If you follow the game plan, you will name this correctly. The first thing you have to do is circle and name the longest continuous chain of carbons. Well, in this case, the longest continuous chain is simply 3 carbons long. When we look up the 3 carbon chain on the back side of the functional group sheet at the top, you can see it's propane. So we have a propane molecule here, but now we need to do step 2 because we have a branch coming off of the propane. So start numbering the chain from the end with the most branches. Well, this branch is right in the middle of the molecule, so it's not going to matter which way we number it from. We're just going to go left to right in this case and number the carbons 1, 2, 3. If I happen to go right to left, I'd still get 2 in the middle. It'd be 1, 2, 3. And the 2 is the thing we want to worry about because that's where our branch comes off of. So we're going to indicate where the branch comes off of. So we're going to say 2, and then we're going to look up this type of branch on the bottom half of the back of the functional group sheet. So if you have a 1 carbon branch, it is called a methyl. So we have a methyl on the second carbon. So we're going to name this 2-methyl propane. The boiling point for this happens to be -12 degrees Celsius. Let's try a couple more. Let's draw the 3 structural isomers for C5H12. The easiest one to draw is simply the long continuous strand of 5 carbons. So if we follow the game plan here, we name the longest continuous strand. Well, 5 carbons long is called pentane. So this is pentane. We can stop here because there's no branches. If there's no branches, there's no need to number the carbons. Pentane happens to have a boiling point of 36.1 degrees Celsius. Another way to draw C5H12 is like this. So if we follow the game plan, find the longest continuous strand of carbons. Well, it happens to be 1, 2, 3, 4. 4 carbons long. Now you might also number it if you want. 1, 2, 3, 4. That's also a 4 carbon chain. And if you did that, it'd be okay because the name you would come up with would be exactly the same. So we identify the longest hydrocarbon chain. It's 4 carbons long. If we look up a 4 carbon chain on the top of our hydrocarbon sheet, then we can see it's butane. And now we have a branch. And we want to make sure we number it now. Step 2 of the game plan, so we get the lowest numbers. So I can number it like this, 1, 2, 3, 4. I could also number it from right to left, 1, 2, 3, 4. But if I numbered it that way, the branch would be on the third carbon. But if you number it this way, it's on the second carbon. You want to make sure you get the lowest numbers. So I'm going to number it left to right again. If we look up the branch, once again on the bottom half of the hydrocarbon handout, a methyl group is 1 carbon long. So this is 2-methyl butane, boiling point of 27.8 degrees Celsius. The final way to draw C5H12 is like this. If you count it up, there's 5 carbons and 12 hydrogens. If we find the longest hydrocarbon chain here, it's going to be 3 carbons long no matter how you look at it. A 3-carbon chain, looking on the back of our functional group sheet, is propane. So now I'm going to number the carbons for the branches, and this one isn't going to matter which way you number it from, left to right or right to left, but I'm going to just number it left to right. If I numbered it from right to left, I'd still have 2 where the branches are. This time I have 2 branches, and they're both methyls, 1-carbon chains. To name this now, we have to identify that we have 2 methyls, so we're going to use a prefix in front of methyl, and we're also going to say where both methyl groups are, and they're both on the second carbon, so we have to indicate it by saying that twice. 2, 2, and then since we have 2 methyl groups, we're going to say dimethyl. So this is 2,2-dimethyl propane. Notice the boiling point is 9.5 degrees Celsius. Notice that as the number of branches goes up on your isomers, the boiling points go down. So let's talk about that for a second. Remember, intermolecular forces are the forces within a molecule, ionic and covalent bonds, and intermolecular forces are the forces between molecules, and they are responsible for things like boiling point. If you look on the back of that sheet, you see that as the number of carbon atoms increases, the boiling point also increases. This is because there's more London forces, because there's a larger surface area on those larger molecules. So therefore, there's possibilities of more London forces forming. You'll also notice from what we've done here in the last couple examples that the boiling point decreases as the number of branches increases on an isomer. This is because there's less surface area on those molecules that have branches. So therefore, there's less possible London forces that can form between those molecules.